In this video, we're going to look at an example where we need to find the sample size. This is similar to what we did in a past section when we were estimating for proportions, just now we'll be using our formula for means instead. Now, one thing to note is that we need to use a critical z-value rather than using a t-distribution, because in order to use a t-distribution, you need to know the sample size, and since that's what we're solving for, that's not going to work out. But essentially the process is the same. We'll be given the margin of error, we'll have to know a standard deviation for the population, and we'll have to find our critical z so that we can then solve the formula for our n value. So here's our problem. We have some researchers that would like to estimate the mean cholesterol level for a particular type of monkey. And what they do know is that they want to be within 1 milligram per deciliter. So that's how much error they're willing to work with. And they want to be using a 95% confidence level. And from previous studies, they have an idea that the standard deviation is about 5 milligrams per deciliter. So we're going through our 4-step process here. So here's our problem. We don't want to obtain more monkeys than needed because it is an added expense for our research. So we want to get the least number possible. So first we're going to find our critical z. You can either use the z table or you can use inverse norm on your calculator. Remember that if you're using inverse norm, you have to take the absolute value of your inverse norm of, now you're going to be splitting this in half since we're only looking at the one section of the graph. So we're doing 1 minus 0.95 divided by 2, and that would give us just that one area of the bell curve. And we're using our mean of 0 and standard deviation of 1. That is where we're getting this critical z value. Again, from past studies, we know that we have a standard deviation of 5, and our margin of error is going to be 1, and we're going to solve for n. So we're taking our values and plugging them into our formula and solving for n. Now also recall that we'll always round up. So even though mathematically 96.04 is going to round down, we don't want to add more error than what we wanted, so we're always going to round up. So we're going to need 97 monkeys for our survey.